So during this video, we are going to be looking at the principle of superposition, which is a really good flow-on from what we were looking at last time, which was Coulomb's law. Now, this title is Limitation to Coulomb's law, and what we mean by that is, last time we looked at Coulomb's law. If we had two charges acting on each other, we had a force between them. But what happens if there's a third charge? Okay. And what we find is that it's not actually a limitation. What we do is we can work out, if we're interested in this charge, I'll put a number 3 next to it, we can work out the force between these two, which would be a repulsive force, a force between these two, which would be an attractive force. Add those forces together and we can find the force that's acting on that third charge. Okay, so the actual definition for that, for the principle of superposition, is if the force at a point is the result of a number of forces due to individual charges, then the total force is found by adding the individual force vectors. So what that means is we've got a point here, Q1, and it's going to be acted upon by Q2 and Q3. So the first thing we can do is we can find the force from 2 acting on 1. So that's what we'll call this force vector here. And we've also found force from 3 to 1. All right. And if we want to find the total force, this total force here, we add those two forces together. So F3(1) plus F2(1) equals this total force here. And we'll have a look at an example now. All right. So for this example, we're looking at part 1. Two charges Q1 and Q2, magnitude 20 microcoulombs and 10 microcoulombs respectively, are placed 50 centimeters apart in a vacuum, and a third charge of plus 30 microcoulombs is placed midway between Q1 and Q2. Find the force on Q3. So the first thing we want to do here is draw a diagram. And that's what I've done now. So the diagram is here. You can see that they are 50 centimeters apart, which I've just changed to meters, which is fine. It's exactly what we have to do. We've got Q1. And I've changed the micro into 10 to the minus 6, Q2, 10 by 10 to the minus 6, and Q3 in between plus 30 by 10 to the minus 6. So what we have to do now is we want to find the forces acting on Q3. So let's do that now. So I've just put those in there. I've removed the question just so we have a bit of room. What we've got is the force of 1 on 3 and the force of 2 on 3. Now you can see all I've done is use Coulomb's law and substituted in either Q1 or Q2 in both. So what we do is we'll just put in the variables now. So I'll just do one of them with you. So we remember 1 on 4 pi epsilon naught is 9 times by 10 to the 9. Okay. Times by Q1 is 20 microcoulombs. Q2 is Q3 is 30 microcoulombs, and the R squared is 0.5 squared. All right, if we put that into our calculator, okay, and that equals 21.6 newtons. Okay, so the first question says, what would happen if Q1 and Q2 were both positive? So if these were both positive, this 21.6 newtons is going to be Q1, Q3 are both positive, so it's going to be a repulsive force. So this will be 21.6 newtons to the right. All right. Now what we'll do is we'll also substitute into this equation for F2 and 3. I won't step through the process like I did, but it's going to be exactly the same. So once again, if we substitute in our numbers, we get 10.8 newtons. And we're talking about F2, 3 now, so both of those are positive as well for this question. So that's going to be 10.8 to the left. Okay, and I'm just going to label those. So this was F2, 3, and this was F1, 3. Okay, so if we have 10.8 newtons to the left, and we add it to 26.1 to the right, what we end up with is our force equals 21.6 minus 10.8, which happens to equal 10.8 newtons to the right. Okay. Now, if you didn't quite get why that is, it's because we have a force of 21.6. Okay, and then we have a force of 10.8. All right, so if we add those together, we get this leftover force, which is 10.8 newtons to the right. Okay, so that's the first example. All right, so part 2, what we do is we have a look here. We want to make Q1 positive and Q2 negative. So if Q1 is positive, this is going to be a repulsive force between Q1 and Q3. And if Q2 is negative, it's going to be an attractive force this way. Now, it happens to be that the force of 1 on 3 still equals 21.6 newtons. Okay, because all we've done is change the sign. We haven't changed the actual values. And the force of 2 on 3 still equals 10.8 newtons. Now, because they're both positive, this is to the right. And this is also to the right. Okay, because they're both to the right, we can just add them together. So the force total equals force 1,3 plus force 2,3 equals 21.6 plus 10.8, which equals 32.4 newtons to the right. Okay, now those two examples were for a straight line. However, we can get triangles involved, and we'll have a look at that now. All right, so we'll have a look at that now, and what we've got is two charges, Q1 and Q2, of 2 microcoulombs and 1 microcoulomb. So this one's 2 microcoulombs and this one's 1 microcoulomb. They are both, well, this one is minus and this one is plus. All right, they're placed 50 centimeters apart, so that means this one's 50 centimeters apart in a vacuum. A third charge of 3 microcoulombs is placed 40 centimeters from Q1 so it is to form a right angle triangle. Find the force on Q3. Okay, so what we've got here is a couple of things. The first one is we have a negative charge up here and a positive charge here. So this is going to be an attractive force. And over here we've got positive and a positive, which means this is going to be a repulsive force. So if I want to find my force total, I have to add my force 1 on 3 plus my force of 2 on 1. Sorry, 2 on 3. Okay, now the force total in this case is also often referred to as just the force on 3. Now if I add those together, we're going to get 1. So the force of 1 on 3 looks like this. And the force of 2 on 1 is straight up. So force 2 on 3. All right, these are at right angles. And it means that the force of 3 is the hypotenuse of that right angle. So now all we need to do is find out these values. Okay, and that's what I've done now. So I've just substituted in to find the force of force on 3 caused by 2. Substitute in those values. You can have a look if you'd like, and we get 0.16 newtons, and this is upwards. Okay, so now I want to find the force of on 3 caused by 1. So I substitute in these values again. 9 by 10 to the 9 times this one here is 2 microcoulombs, 2 by 10 to the negative 6 times by Q3 is 3 microcoulombs, and I divide it by the distance between. Now we don't have the distance between here, so what we have to do is we know this is a right angle and we have to work out the distance. So if you want to know the distance, it's in meters. It's the hypotenuse squared minus this one squared. So that's just Pythagoras, and I've rearranged quickly. So if you get a bit stuck, I can show you exactly how to do that. But what that equals is 0.3 meters. And that's what I substitute in here, 0.3 squared. Okay, now we just whack that into our calculator. And if we put that into our calculator, it equals 0.6 newtons to the left. So what we can do now is we can come back over to our red side. And what we know is 2 on 3, this is 0.169. And this here is 0.16 newtons. So f of 3 equals the square root of 0.169 squared plus 0.6, so this should be 0.6 squared. And if we put that into a calculator, we'll get an answer of 0.623 newtons. Okay, now we're not quite finished yet because you have to give an angle here. So the angle, you can't just say, this is pointing kind of, I don't know, northwest. You can't say that. You've got to give an exact number. So I know the adjacent and I know the opposite, so I can just say tan of theta equals the opposite, 0.169 over the adjacent, 0.6. If I want to solve for theta, I just find the inverse tan. All right, substitute in that calculator again, and I get 15.7 degrees. So just finally to wrap it up, what you should do is write a finishing sentence. I'm running out of a little bit of room, but that's fine. I will write the force on 3 equals 0.623 newtons at 15.7 degrees as shown. All right, and that's how we do these principle of superposition questions. Thank you.